as I was saying. Maybe crop the beginning because we did not start yet. All right, so so I was saying if you can put your camera on, it will be good for the session, unless you have internet issues. Thank you, Shadi, for that. Okay, what is the plan for today? I want us to have a quick look at our Google Classroom. You have a tiny homework for today and that's it. The reason why you don't have much to do is because I need to continue the lesson. Like we stopped because of the quiz and now you can move on. So I'm gonna go and find the file. What's that? Okay, I don't care about it. So go find your file.
Miss, so when are we gonna collect the homework?
No, we're doing it now. Okay. All right, I'm just opening the file. Maybe I should remove some windows. All right. So let me, before we start homework correction, let me discuss a bit of what we did so far. And basically, we did basically nothing. It was only introduction for the course. And let me keep your faces so I can see you. So as you can see.
Miss?
Yeah.
Leo says his Wi-Fi is currently out and he's using his phone and his phone is low on battery. So in case he exits the meeting, you know why.
Okay, thank you for informing me. Hello, Wissam. Are you late for a reason?
I didn't notice we had a homework, so I did it real quick and then
Why didn't you notice? Is there a reason?
Like not really. It just took time to load the screenshot, and that's why I'm late.
No, my question is, how come you didn't know we have homework? Is there anything with the notification I'm sending that is not working?
No. It worked, but I forgot to do it, and I just did it right now. It was like really easy.
Yeah, I know. It was quick and easy. All right. So in your absence, we wanted to start the lesson, like start with a quick review, and then correct the homework. So far, what we did is define the kinematics quantities. We said kinematics is description of motion, so we only care about the how. And the only way to describe is to discuss. You tell me a few words. How do you describe the motion? What do you use? Distance covered. What else?
Distance and time and direction.
Direction. What else?
Displacement.
Displacement. Yalla, say something. Velocity. Acceleration.
Velocity is okay.
All right. So all these are quantities used in kinematics. Okay. I'm expecting 10 students and 2 of myself, so 12, which means 1 student is missing so far. Could it be Tony? Yes, I guessed right. So Tony is missing. All right. So let me close this. Okay, I'm sorry. This is really slow due to the fact that I'm recording the session. All right, describe 2 types of motion. We did not start with this one yet. So the homework was, actually, this is a nice application we did given by Wissam. And this is the homework that you guys did few hours ago. So let me call it homework, mark the date and correct it, okay? So homework for you guys. I'm gonna, by the way, fetch your answers from Google Classroom because I think it's a little bit fun to correct your work and I believe it's a little bit beneficial as well. So why do the homework and not use it in our correction? So go to your homework. Yes, hopefully these things are gonna be fast. I'm gonna look at Kifah's work. All right, usually if your homework takes time to open, it means that the file is big, all right? And again, you can simply solve on a piece of paper and take a picture. I know that Kifah and Wissam would rather type the work, okay?
But on my phone, the picture size would be like bigger than the document itself.
You will find a way to scan it because eventually this is huge. Okay, I cannot take a screenshot of number 1. Maybe number 1 is big anyway. So
Miss documents are always gonna be like smaller file sizes because they're just facts.
Okay.
I just wrote on the screenshot you sent because it's like really easy. It doesn't need much work.
Okay.
I don't know why people wrote this much.
I just want you to train yourself for a quiz or test later on. When you have a test later on, I don't want you not to be able to scan, because scanning needs some practice sometimes. I took Tony's work as well. I know Tony is not with us, but maybe he's gonna join in a moment. And let me insert both works. So insert both pictures and correct on them, so we can see your mistakes, and I like this. Okay, so these are the two screenshots, and now we're ready to go. Hadi, can you please read number 1?
Yes, miss. A car must be driven at a distance of 120 kilometers in 2.5 hours. During the first 1.5 hour,
Yeah. The average speed was?
the average speed was 70 kilometers per hour. Calculate the average speed for the remainder of the journey.
Okay, so as I can see that you have different parts of the trip. So this is the total distance, right? A car must be driven a distance. This is total distance and total time. The first part of the trip, I had 1.5 hours and the average speed. So this is the first 1.5 hours. The second hour, I know nothing about it. All right, I need to find the average speed for it. If I look at the solution, I can see that you, or I don't know whose solution is that, but it doesn't matter. Let's keep it anonymous. I can see on the solution that you have time 2. For distance 1, you did speed 1 and time 1, and the units are actually nice. So you ended up with the distance, the first distance. So you found the distance for item 2, for trip 2, and did you do the speed? I don't see why not. Do you agree with this, Hadi?
Yes, that's what I did.
Okay. Everybody agrees with this one?
Yeah, that's how I do that, Kevin.
All right, I do agree with this one. Please speak up if you don't agree. So it's very important, never, I don't want you to find the average doing speed 1 plus speed 2 divided by 2. You have to use distance as...
Miss, I have a question.
Yes, please.
I got that answer and everything, but would you take out marks if I forgot the unit?
Usually, yes, we do remove marks. Not a lot though. Not a lot though, but be careful. For the homework, listen up. For the homework, we don't, I actually need to grade your effort, okay? But I will definitely write a note stating that you did not put the units, okay? Just be careful about it. Ivan?
We should just put the units for our own sake because they really help. You can actually deduce the entire formula. You can just not memorize any formula and just know the units.
Yeah, but anyway...
So if you know that it's a kilometers per hour, then you know it's distance divided by time.
Yeah, you're totally right, Wissam. That's why we do it. But now, talking of IB and talking about the Lebanese curriculum, they both remove a quarter of a point and sometimes more every time you miss a unit. Okay? All right. Anyway, so...
Yeah. I never miss a unit. Yeah. I try to at least.
All right. Are we done with number 1? Can I assume no questions about number 1? All right, yeah. Ivan, can you please read number 2? Let me look at you.
Okay, 2 cyclists, A and B, start moving at the same time.
Yes.
The initial position of A is 0 meters and the velocity is positive 20 kilometers per hour. The initial position of B is 150 kilometers and he cycles at a velocity of negative 30 kilometers per hour. So you have to determine the time and position at which they will meet.
All right. So is Tony with us or not yet?
Miss, for some reason, I forgot to do the position.
It's okay.
I did at the time.
Okay.
I'm sorry.
It's okay. All right. So if I read Tony's work, Tony, please speak up if you are with us. They said he basically wrote the given, and all he said is they will meet after 3 hours. B would have gone 90 kilometers and A would have gone or done 60 kilometers. Okay. Do you agree with his answer?
Yeah.
But how did he guess? Maybe he did trial and error. Maybe he tried and
I did a system.
I did it like with an equation.
okay, I would do
I did a
that.
system of equation.
Yeah, personally, I'm very mathematical and I would want to write the equation and solve it. But I would be happy to see answers like these because it shows that you do understand the concept well. Although these are a little bit tricky, and sometimes if the given is not super clear, maybe you will not be able to do a conceptual answer. And I call this trial and error. What I mean by trial and error, you try. What happens after 1 hour? What happens after 2 hours? Kirill, can you please speak up? What was the method that you used?
I did so A plus minus B. So I did 20x plus 30x is equal to 150. Because if they meet at the same spot, then their distance should be equal to 150. The distance between B and A.
Yes.
Yeah. So I did that, and I did 20x plus 30x is equal to 150. And so x is going to be equal to 3. And x in this case would be the time.
Okay.
And then I got x equals to 3 hours. And then if you multiply the 20 times 3, 60 kilometers from A's initial point and 90 kilometers from B's initial point.
Okay. So basically you got the same answer as I
did
can see.
something.
Yeah. You have the same answer, Kirill, as I can see. It will be much better. Wissam, I can hear some background noise. It will be much better, Kirill, if you put instead of x, t. Let it be t your variable. I know in math, x is always your variable. In mechanics, t is always the variable. Just make it as an extra step and habit. Shadi, did you get the same answer? Shadi, you are muted.
Oh, okay. Yes.
Okay, so I assume, let's say that you can do whatever you want as long as you end up with the same answer. Okay, this is not a super difficult question. You can still get the same answer. All right, so now I suppose we can move up and start.
Miss, so if someone did x equal 20t, x equal negative 30t plus 150, and then a system of equations. Is that just?
Yes. This is awesome, actually. This is gonna be awesome. All right, so I'm gonna start now with item 2. For the students who are taking notes, you can get ready. Can I assume Tony is still not with us? So I'm expecting 12 participants. No, Tony is here. Tony? Hello? Tony, I need you please to speak up. Waiting for Tony to speak up. Like seriously, I need Tony to speak up. And if Tony is not answering, it means Tony is not with us, or probably he cannot hear me. All right, anyway, if you have any feedback about Tony, let me know. Describe 2 types of motion. All right, I'm gonna give you 2 examples and you tell me the difference between these 2 examples.
There's more than 2 types. So.
Yeah, I'm gonna only describe 2 important types, and definitely we have like many types. I can go up to 5 different types. By the way, we will study 1 more type this year, actually 2 more types, but let me focus on the main, like the easy 2 types. The first example.
You mean like URM or UARM?
Yes, so the first example I need to consider is the following. A car moving.
Miss Tony wrote on the chat, he heard his name, but he didn't hear anything else.
Can you please ask him why? Is it internet connection? A car moving on the highway.
It probably is, yes.
Okay. So a car moving on a straight line at a constant speed. This is one. Second example, and here I need to ask Sharbel to speak up. So the second example is a car moving on a straight line speeding up. Okay? And speeding up. Sherbil, can we talk, please? May I talk to Sherbil, please?
Yes.
Okay, so Sherbil, can you check the difference between these two motions? So tell me what's different and what's common. So what is common and what is different?
The common is that there are two cars moving on a straight line.
Okay.
The difference is that the first car is going on a constant speed, while the second one is moving and it's accelerating.
Okay, constant versus variable speed. Okay, Wissam, can you please give a name for both motions since you know?
Uniform rectilinear motion.
Okay, so I'm
And
gonna
uniform
call
accelerated.
okay, the first one is gonna be called URM. The second one is gonna be called UARM. This one stands for uniform rectilinear. Please, every time you talk.
And I can explain what that means.
Okay, give me a moment, please. Every time you talk, everyone, please mute yourself when you're done. Okay, because I can hear some background sound. So uniform rectilinear motion for the first one, and the second one is uniformly accelerated rectilinear motion. I need to ask George, but George cannot speak up, right? Maybe ask Hadi instead. George, I want your microphone to be working with soon. I hope you can fix it. Back to you, Hadi. Yes, so Hadi.
Yes, miss.
Yeah, Hadi, so the first example is URM or UARM?
The first example is URM.
Okay, so it's URM. What about the second example?
It's UARM
Are you sure?
because it's speeding up.
It is speeding up, but speeding up, does it mean uniformly accelerated? Maybe it's not at a uniform acceleration. So only if A is equal to a constant. Okay, and here we have to define what A is. So we can only say UARM if we have uniformly accelerated, meaning it's a constant acceleration. And mind me, during all of high school, your acceleration is gonna be either 0 or constant. Don't worry about a variable acceleration because it's not gonna happen anytime soon, okay? Now my question
Why?
I'm sorry for that, because we believe in education, if you can master easy examples and ideal cases, you can do well with real cases later on, okay? So it's not like we're lying on you, because initially when I was at high school, I was actually upset and I was telling my teacher, you lie to us because you give us examples that are ideal, no friction, and this does not exist in real life. And later on, I realized that the only way for you to be able to solve real problems with friction and variable acceleration is to master the easy ones first. So now in high school, your job is to do so well in those to be able to expand it to later on. But I think, Wissam, I can try to teach you a method through coding to include some real stuff in your problem. Hopefully we can do this soon. We can write a computer code and add friction to our problem. I would love to do that with you. Okay, so get ready for a lot of virtual labs and a lot of...
Yeah.
Yes, we're doing
But
that
like
very
we
soon.
won't take terminal velocity and jerk and
we can do that
stuff
through experimental work, virtual, experimental, and coding. Okay, we'll see that. Now I need somebody to define acceleration. I did not talk to Kifah today. Kifah, how do you define acceleration?
Acceleration is the change in velocity if it is uniform at a constant rate.
All right, so I'm gonna call it change in velocity. Change in velocity. Maybe I can ask Tony again. I hope he can talk to me. Tony cannot talk to me. Maybe Leo.
Miss Tony can't even hear us.
Yeah, I'm so sorry it's happening. Although Anna has no problems, it could be his device. No, Anna is not his sister. Tina is his sister, right? So Tina has no issues, so it could be his device. Yes, I will see how I can help him. So thank you, Ivan, for assisting me. Leo, can I talk to you? Or maybe Leo is out? Not yet? All right. Can you please remind me what is velocity?
Velocity is change in acceleration.
It's actually speed and direction. I don't know if you said that. All right. Now, do you agree with the fact that acceleration is change in velocity?
Yep.
Okay. I need Kirill to help me with this one. Kirill, what is the unit for velocity?
Meters per second.
And the
Kilometers
unit,
per hour.
yeah, meter per second is good for me. What is the unit of the change in velocity?
Meters per second squared.
No, it's basically velocity
meters per
minus
second.
velocity. It is meter per second. What is the unit for acceleration?
Yeah, meters per second per second.
All right, so the acceleration is meter per second squared, and the change in velocity is meter per second. So there's something missing in this statement. So do you see this statement? There's something missing in it. Who can guess? And Kifah, you can speak up if you want to say something about it.
The direction. It could be either the change in the speed or the change in direction.
But Kifah said
For
velocity. So wait. Kifah said velocity, and there is direction inside velocity. So there's nothing wrong with that. There's something missing because the unit does not make sense. Meter per second squared.
And velocity over a period of time now.
Exactly. Thank you, Kifah. Thank you, Kirill. I heard you. So it has to be per time. So I'm gonna call it rate at which our rate of the change. So what we mean by rate means divide by time. So if you don't like rate, just say change in velocity over, all right, divided by time. Okay. So all right, here I'm gonna move to a new document and try to write some equations that we can use. And later on, I'm gonna help you by creating a way to remember those equations. Okay, so maybe split my table into two parts. And I like this. One part is for URM and one part is for UARM. So this is like a summary we can use later on. I need the help of Shadi. Shadi, remind me what is URM? How do you define
URM, it's uniformly rectilinear motion.
So what do you know?
Like move.
Okay, what do you know about the acceleration of it?
Yeah, I'm just going to moving at a constant speed.
Okay, constant speed. Okay, what is the acceleration in this case?
Zero.
Zero. What is the velocity?
The velocity is it's distance over time.
Yeah, can I say it's constant?
Yes, yeah.
Can I say it's equal to the initial velocity?
Yeah.
Okay, I'm gonna call it U. Okay, so now I need to define some terms. A is the acceleration. Okay, V is, I'm gonna call it final velocity. So these are new terms that I need us to use, and U is gonna be the initial velocity. Some students used to call it V0 or V initial. Let's call it U. Okay, continue. How can I find now my position, Shadi?
Your position is V final. Damn it, miss.
Can I say Vt plus x0?
Yeah.
Okay. I would want to call my distance S. S could be x, could be y, could be anything. And I can simply call this as 0. Let me call it as 0 if you want. V or U, it doesn't really matter because they're the same. Now, Shadi, stay with me. What can you say about the acceleration?
Constant.
Yeah, thank you so much. I'm gonna say it is a constant. What can you say about the velocity?
Not constant.
Okay, so it's equal to u plus
velocity.
something. So it's equal
Yeah,
to
it's-
the initial plus something. What is this something? Maybe take, maybe take a break for a moment. I want to write something. Can you help me, Shadi, to write this sentence into a mathematical equation?
Which sentence?
This, the red one.
Yeah.
So acceleration
A is equals to change its velocity. It means,
so how do I write change in velocity?
a change in velocity.
Can I say final minus initial?
Yeah.
Okay, so I'm gonna call it V final, which is V. And the initial, what do we call it? We're gonna call it U.
Initial VI.
So I'm gonna call it V minus U over time. Do you agree?
Yeah.
Okay, let me draw it nicely. Okay, now I want you please to use this equation, Shadi, to write down the V equation in here.
The what?
The V equation. So V is equal to U plus what?
Okay.
Yeah.
Yeah. V is equals to U, damn it, equals to U times A plus A times T.
Okay, awesome, so much. All right, now I'm gonna continue and state S. S is gonna be equal to S0 plus UT plus half AT squared, okay? I know
Miss,
that...
can I explain how it's derived?
Say it again.
Can I say how it's derived?
Yes, please, I need your input.
Okay, so basically this, so we have, for example, a constant acceleration. So in the graph, the velocity would be increasing linearly at a constant rate. So, and the graph would be on the y-axis is velocity and on the x-axis is time.
Okay,
and
can I stop you? Can I stop you, Kifah? And maybe you can help me do the graph skills before we continue. All right.
Okay.
So since you want to discuss that, I want to do that with you. So let me do the graphs and you talk through it. Okay, let me insert a column to the right to put all the definitions. So those definitions, I'm gonna put them in the table here, and maybe add T later on and S, but let's do this later on because I'm not in a hurry. Okay, all right, now for graph skills, I want us to show basically 3 graphs, or to make your life easy, let me focus only on 2 graphs. The 2 important graphs here, although I remember there is a section graph skills, maybe wait until we reach, you see the graph skills, position time, velocity time. So can we wait, Kifah, until we reach item 4? So you can tell me more about it?
Okay.
Okay. So, you see, my computer is lagging due to the recording. Every time I record, I have this issue. Like I do stuff, it responds later. All right, so I'm happy that we're done with the URM, UARM. We discussed each. We gave an example. We discussed real versus ideal case. We gave in the equations. I would want to add some equations to make your life happy. You know, you will be asked sometimes to calculate, let's say, the speed without knowing the time. So usually you find time from one equation and then you replace it in the other equation. And this is really time consuming. So that's why we did the work for you, and we can directly tell you that you can simply, let me remove this, you can simply say V squared to be equal to U squared plus 2AS. Let me just fix this. So now I'm writing some equations. By the way, those equations are gonna be given to you. I have some good news for my grade 10 students. The DP students can have their equations during quiz and exam, which means if I allow it for DP, I need to allow it for grade 10. How do you feel about it?
Yeah, that's true.
Anybody from grade 10?
Sure, miss.
All right, so I'm saying that I want to allow my DP students to have their equations on them every time they have a test or an exam. So I need to give them a list of equations to use during the exam, which
Yeah.
means I need to do the same with you. How do you feel about it?
Not good.
So you don't want to be given the equations?
مستر انه نحن اللبنانيز for future بدنا نحفظهم ما حيكون
let's just give it to us. خلاص.
How do you know you need them, Shadi?
Shadi, if you don't need them, don't look at them.
Yeah, okay, هاي خلص.
Shadi, what do you know about your future? You know nothing about your future. Shadi, you will use them a lot and you will end up knowing them. You don't need them, you know?
Exactly.
So, but I want us to do this because this is the only way for me to give you difficult questions, like give you the equations. So which means I don't have to test you for equation anymore. I can test you for difficult questions now. You know, I'm joking. So anyway, what I'm trying to say is, for the URM, you can use those definitions. For the UARM, you can use those definitions. I suppose we should, okay, I can put this to be U. You see, those equations are similar. If you put A equals to 0, you can end up with those, I suppose. Do you agree? And those two equations, if I put them in green, are actually a derivation of the first three. So if I take the first three, find T from this one and plug it in this one, I get this one. But for you not to do it every time, we can write it down. This one states that the distance covered is V initial plus V final divided by 2. That will give you the average velocity, by the way, in case A is constant, be careful. And you multiply by time. So it's like average velocity times time. You can use it. So T, I'm gonna call it the time taken. And S, I'm gonna call it it could be position, by the way. It could be displacement. It could be distance covered, depending on the question, okay? Let me fix my table a bit because I'm done, and maybe wrap up the session. I need somebody to help me with the units. And this somebody is, Ivan. So I did not talk to George and Tony today. Please do something about your problem. Let me help you if I can. I did not talk a lot with Leo as well. So Ivan, tell me about the units. Ivan. Not with us. Maybe Sharbel. Sharbel can speak up. No?
Yes.
Okay, Sharbel, what is the unit for acceleration? I need a reminder.
Repeat.
Do you know the unit for velocity?
Mr. Voice is glitching عندي شوي.
Okay, can you please tell me the unit for velocity?
It's for velocity is meter per hour.
Okay, meter per second is the SI. Do you believe that the final velocity and the initial velocity are the same? Same unit?
Yes.
Okay, time. What is the unit for time?
It's second.
Okay, unit for acceleration.
For acceleration.
Anyone? What's the unit for acceleration?
Meters per second squared.
Okay, meter per second squared. Yes, thank you, Leo. Thank you, I think, Kifah or Hadi. And unit for position, back to you, Sharbel.
Meters.
Meters, okay. By the way, this is called the Suvat equations. All right. So Suvat, can anybody tell me what I mean by Suvat?
SI unit. Nope, I don't know.
These are all the units used in the lesson of motion.
All right, so basically Suvat is S-U-V-A-T. Every time you see a mechanics problem where you are given S, U, V, A, or T, you simply create a table You call it SUVAT. Let me show you how the table looks like. It's a table, but we're gonna do that later on. So 1, 2, 3, and up to 5. Okay, so you're gonna write the S, you're gonna write the U, you're gonna write the V. So this is how you write your given in a table. Okay, usually one of these is a question mark, and usually one of these is not known. So if you know 3 and you are asked about the 4th one, it's gonna be okay. Which equation do you use? You use any equation you want. If you have 0 acceleration, you can use the URM. If you have 0 acceleration, you can use the URM. Otherwise, you can use any of those equations. They will all give you the same answer actually, so no need to worry about it. I'm gonna leave you now. Next time I see you, we're gonna talk more about SUVAT and do practice. So going back to my outline, we did description of 2 different types of motion. This is done. And for the SUVAT, I'm gonna discuss it more next time and do problems. STAR means practice, okay? And take a break to practice and keep the graph skills to later on. So Hadi, was it Hadi or Kifah? Kifah actually, remind me to discuss, I want your input for graph skills, okay?
Okay.
All right, I'm gonna save it. Enjoy your day.
See you, Miss.
Bye.
Bye.
Bye.